If you've ever opened up a banana, you've probably noticed that there's no seeds inside of it. But how does it grow from trees? How can it reproduce? Well, the answer to those questions is simple yet complicated. They're genetically modified. The first genetically modified food was the Flavor Saver tomato in 1994. With hopes that the tomato would hold a longer shelf life before ripening, the company Calgene inserted a specific gene into the tomato that allowed this to happen. I had 30 willing participants of different age, ethnicity, and profession eat 2 apple slices out of 2 different boxes. After trying both, I asked them which one they preferred. What I didn't tell them is that both boxes had the exact same type of apple, and I had no idea which was GMO or not. While some people could not care less which apple they ate, 50% of those who found out they liked the genetically modified apple better almost seemed disgusted in themselves that they were eating something with chemicals. One man even asked if there was a bathroom he could throw up in nearby. I think he was joking, but nonetheless. After no one could give me a straight answer as to why they dislike GMO food so much, I decided to turn to our trusty friend Google. Turns out that the main reason many people hate GMO food is because they associate the genes entering the food as foreign and foreign things as dangerous, with even some comparing these genetics to bacteria and disease. Now, everyone I asked associated GMO foods with bad things, but why would science ever create something to harm us intentionally? Well, they didn't and they don't. Despite what the majority of people think, GMO foods were created with the intentions of better food so they can better our lifestyle. Famously, there were scientists who not only wanted to create a more friendly and useful food, but a food that would be able to help people. It is estimated that 1/3 of deaths of children under 5 are a result of this, vitamin A deficiency. Scientists have taken a food that almost all nations have access to in some form, rice, and genetically modified it so that it carries a significant amount of vitamin A. They call it golden rice. For every person who sounded disgusted by GMOs or relieved that they hadn't ingested such foreign material, I asked them a question. I asked them to imagine a scenario of which they were dying of hypokalemia, a potassium deficiency. I was the doctor and I was offering you your options of treatment. In the left bin, I had my normal apples, and in the right, I had GMO apples. Now, would you rather have a food with insufficient nutrients to survive, or food where you'd be well on the way to recovery? Every single person said that they would choose the GMO apple, but weren't you all just appalled by the thought of eating foreign genetics? And this is where my thesis came in. Our society is so focused and primed to believe the most prevalent thought we hear, that we fail to think and learn on our own. We create conclusions knowing so little about topics because we're too lazy to research and to think on our own. We fear rejection if our thoughts contradict the majority population, but where would we be if people still believed that all bacteria was bad? In my survey, I asked whether or not my participants had ever heard of CRISPR-Cas9, and only 6%, or 2 out of the 30 people I surveyed, knew what this was. And while it's a relatively new discovery in the field of medicine, I was still shocked. CRISPR is a family of DNA sequences that can be found in bacteria that come from DNA bits and pieces from viruses that have previously infected said bacteria. The Cas9 part is an enzyme that uses the DNA sequences in CRISPR to recognize certain strands of DNA that could complement a sequence. This thing is used to edit the genes of organisms. It's like biological scissors that can go into your DNA and change the nucleotide sequences into something that fits nice and perfect. Like genetically modified food, CRISPR has altered the DNA of biological organisms. It's been able to change mosquitoes so they can't transmit diseases like malaria. The coolest thing to me is the idea of organ transplants. Organs such as the heart are huge working parts with billions of cells working every second to keep it functioning. But some diseases kill off small fragments of the heart. And would it be useful to replace the entire heart when most of it's still functioning properly? Maybe, but it'd be kind of difficult. Through the use of stem cells, which are cells that can differentiate into more than one type of cell, CRISPR would be able to generate cells that aren't working in the heart and substitute them in, rather than replacing the entire heart. Well, this sounds great and all, doesn't it? Well, I asked my participants one more question. If your 3-year-old daughter was born with Huntington's disease, a genetic condition affecting cognitive function and neurological status, would you consider having her genes edited today to remove the Huntington's disease genes, allowing her and any future generations to not have this disease? Well, all 30 people I questioned said yes without hesitation, and I don't blame them. I feel like I really tore at their heartstrings. But how naive. I even gave them the option to learn a little bit more about gene editing first, but every single one of them still said they'd have their children's DNA changed today. One woman even said, "I'd give my own genes to her if I could." And I think that statement in itself shows how little some people know about genetics. Now, this whole time I've been telling you about all of the wonderful and amazing things that gene editing will bring us, but I bet you haven't even considered the pitfalls. Take Joubert syndrome, for example. It is a rare genetic condition that affects the brainstem and neurological and developmental functions of children. There are more than 10 different genes, with most on separate chromosomes. Some of these genes code for many things. What may result in a loss of vision in a JS patient could also help with their molar teeth development. My point here is that the science behind gene editing with diseases with multiple genes is nowhere close to being ready, yet everyone I surveyed was ready to change their daughter's genes today. On November 25, 2018, a Chinese researcher became the first person to create CRISPR-edited babies, twin girls named Lulu and Nana. Although this case is recent and the details have yet to be analyzed or even found to be true, he is literally creating babies. In a world that prides itself on advancement and diversity was one mistake, and now one step closer to having every baby born the same. Imagine 20 years from now, you walk into the doctor's office for your ultrasound appointment. It's confirmed your family will be growing by one. Following congratulations, the doctor asks you to fill out what seems like a book for what you want your children to look like. Blonde or black hair? Blind or nearsighted? Are there any mitochondrial problems you want? Even though that researcher's editing was only focusing on one gene, he still used this powerful tool for evil. The full effects of editing this one gene are yet to be understood, and considering there are roughly 20,000 protein-coding genes in the human body, we're worlds away from understanding how gene editing could affect them all. So knowing this, would you let your daughter's genes be edited to rid Huntington's disease today still? Would you risk ruining other genes, any misedits for the future generations? As with genetically modified food, there is a reputation that CRISPR and genetic editing are godlike. Like something has the potential to cure the disease can do no wrong, like there's no bad sides to it. Now I have one challenge for you. It's that before you make any assumptions or an opinion on a topic, whether that be the quality of the buffalo savers, gene editing, or the effects of eating junk food all day, I want you to think for yourself. Good night, sleep tight, and don't let the GMOs bite.